Spit better than the chick on wire. Rhyming sound like you robbing. I don't feel what you vibing. Pick, see how you describing.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now I wanted to show you an example of a titration calculation. So a 5 milliliter sample of 0.34 molar HCl titrant was added to 25 milliliter sample of 0.25 molar sodium hydroxide. What is the resulting pH? So let me just draw a simple diagram for you. So this is the burette, and it's saying the titrant is HCl. So we're titrating HCl into a flask containing sodium hydroxide. And we start out with 25 milliliters. And we have to know what the resulting pH value is after we had titrated 5 milliliters of the acid. And so since this is a strong acid and a strong base, we can use the concentrations. So first let's figure out the moles of OH minus. This is going to be from the molarity of the sodium hydroxide as well as the volume. So we have 0.0250 liters, since we have 25 milliliters, multiplied by 0.250 molar. This gives us 6.25 times 10 to the power of -3 moles. Remember, the reason why we can do this calculation is because molarity is moles per liter. So we're just solving for moles right now. Now let's also calculate the moles of H3O+, where we have 5 milliliters of this concentration, so 0.005 liters multiplied by 0.34 molar. Again, always remember to change the unit of the volume to make sure that it matches that of concentration. And we end up with 1.7 times 10 to the power of -3 moles. So after this titration occurs, the moles of OH minus remaining, since you can see that the number of moles of OH minus is greater than the number of moles of H3O+, we just subtract the two and end up with 4.55 times 10 to the power of -3 moles. The final volume that we reached when we added 5 milliliters into 25 milliliters is 30 milliliters. So now we can figure out the molarity of the OH minus ions that are remaining. So this is going to be the moles of OH remaining over the final volume. And this is going to be 4.55 times 10 to the power of -3 moles over 0.03 liters, and we get a value of 0.152 molar. So remember, this is now the concentration of OH minus. We can figure out the pH from here, right? pOH is the negative log of the OH minus concentration, which in this case was 0.152 molar. And we get a value of 0.82. So the pH is going to be 14 minus the pOH, which is 0.82, and we get a value of 13.18. So the pH that you get at the very end of titrating a strong acid with a strong base is going to be 13.18, which is pretty basic.
Show you where the devil is. I'm a nice guy. I get your girl in a pair of wigs, cause she need that crazy glue your lips together. If you give me